Welcome back to a new machine learning tutorial. In this video, we are going to talk about the decision tree classifier algorithm. We are going to talk about the logic behind the algorithm. We are going to code it. We are going to talk about the model's parameters. And we are going to talk about how we can do hyperparameter tuning using Python Scikit-learn. Let's start coding. I'm in Visual Studio Code interface right now. This is going to be the code editor that I will be using in this video. But you can use any code editor that you want. PyCharm, Google Colab, completely up to you. And I'm going to be closing the welcome page. And let's create something like decision tree classifier, and it's going to be a Jupyter notebook. Now I'm going to select my kernel quickly, and then I will say decision tree classifier like this. Now let's talk about the concept. So this algorithm, decision tree classifier, is a machine learning algorithm used for classification tasks. Also, I'm going to write some keywords when I'm talking, only the important ones. So it models decisions and their possible consequences as a tree-like structure. So you can see it's named decision tree, and where each node represents a decision based on a feature and branch represents the possible outcomes. The tree is built by recursively splitting the data based on features that maximize some criterion of purity or information gain, such as gene impurity or entropy. And in this tutorial, we are going to start by creating a data quickly, then we are going to train a base model, and then we are going to do hyperparameter tuning. On the final step, we are going to talk about the decision trees parameters and how we can optimize them. So after this video, you are going to be able to code a great decision tree model. So let's start by doing our imports. I will say from scikit-learn.datasets import make classification, and I'm going to say from scikit-learn.model selection import train test split, from scikit-learn.tree import decision tree classifier, and from scikit-learn.matrix import accuracy score. So make classification is for the creating the dataset, train test split for splitting our data. We are going to train our model with the training set, and we are going to test our data with the testing set, and the decision tree classifier for the algorithm, and accuracy score is going to be our error metric on the classification. And we will say x and y. Let's say make classification, number of samples is going to be 1000, and number of features is going to be 5, number of informative is going to be 3, and number of classes is going to be 2. So let me call the x matrix firstly. So we have a matrix like this, we have 5 features, and let's call the y vector like this. So we have a binary classification problem because we have zeros and ones to predict at the target side. And now I'm going to do train test split. So I will say x train, x test, y train, and y test, and it's going to be train test split. And I will say like x, y, and I'm going to set the test size as 0.2, which means that 20% of the data is going to be in the test set. Like, let me quickly show you my test, and 80% is going to be in the training set. Since we have 1000 data points, we have the 800 in the training and 200 in the testing. So I have a tutorial on this topic on my machine learning tutorials playlist, where I have 40 videos just like this one. You can check that playlist if you want to learn more about it if you don't know, but I'm going to be quickly talking about it right now. So we are going to be training our model with the x train and y train in here. Then we are going to make predictions with the x test value we have, and we are going to compare the predictions with the actual y values for seeing how accurate our model is predicting. So I'm going to initialize the base model like decision tree classifier like this, and then I will say model.fit x train with y train. So now we have our base model decision tree classifier in here. The next step is going to be saying model.predict, and I will pass the x test. So here are our predictions, and here is our true y values. Now we are going to compare them. So how we are going to do that is, let me delete this too. We will say Y predictions is going to be model.predict x test like this. And now I'm going to get accuracy score, y test, and y predictions. So let's get accuracy here. It's 0.89. By the way, the higher the accuracy value you have, like the closer it to be 1, the better model you have. You can think it like this. Great. So this is how we can train a base model, and now we are going to talk about the decision tree classifiers parameters. So let's firstly talk about them, and then we can define a grid. Then we can do hyperparameter tuning for finding the optimum parameters. So we have criterion, and this specifies the function to measure the quality of a split. Options are Gini and entropy. We have max depth as parameter, and this is the maximum depth of the tree. Limiting this prevents overfitting. And next up we are going to have minimal sample split, and this is the minimum number of samples required to split an internal node. Increasing this value can prevent overfitting. And we are going to have minimum samples leaf, and it's going to be the minimum number of samples required to be at a leaf node. This also helps in controlling overfitting. So let's implement it. We will say from Scikit-learn model selection import grid search cross-validation, and we are going to define the parameter grid like parameter grid, and again I'm going to say firstly criterion, and we are going to have Gini with entropy in the side, and at the max depth side we are going to have none, 10, 20, 30, 40. You can extend this list, it's completely up to you. Like you can train the model, get the best working parameters, and if you find the best performing parameter like 40, you can extend the list in the side. Like you can add 50, 60, completely up to you. And I will say minimum samples split, and we can say 2, 5, 10. Again, you can extend these values, and we can say for extending these values, like if you extend these lists, you will have more chance to find a better performing model, but it's going to be also meaning that more computational resource. So I'm going to initialize the grid search, like grid search cross-validation. Estimator is going to be the decision tree classifier, and parameter grid is going to be the parameter grid we define. And next I'm going to be using a lowercase letter in here. Next I'm going to set the cross-validation as 5, so it's 5-fold cross-validation. I'm going to set scoring as accuracy. So here is how we are going to set our grid search. And now I will say grid search .fit. I'm going to perform the grid search on the training data. Train with y train. Now we have our estimator, optimized model. Let's get the best parameters like grid search best parameters. And here is our best parameters. Gini for criterion, max depth is none, minimum samples leaf is 5, and minimum sample split is 5. So how you can reach to a better model? You can just extend these values. Let's say you get the minimum samples leaf 5. Let's add 6, 7, 8, 9, 10 for finding a model that we can see will perform better. I'm not going to do that, but it can be the methodology. And what I'm going to do next is I'm going to show you how we can use this grid search set model. Like you can directly use predict on that, or let's say that you want to say best estimator that predict. You can make predictions with that. Also you can get like feature importances like this. And now what I'm going to do is I will say like I'm going to save this best estimator like best model, and it's going to be grid search best estimator. Now I will say y predictions best, and I will say best model dot predict x test. So we are going to have the predictions with this code. Let me quickly show you the binary values, and we are going to compare them with y test right now. So I'm going to be storing it in here. Next, what I'm going to do is I will say accuracy score I will give y test with y predictions best. And here is our accuracy score. So we found a lower value compared to the base model we have in here. It's because our grid in here, like we don't have a lot of values in here, so it picks the best working one in these combinations. But maybe the parameters on the base model is better performing than this, so you can improve this performance 100% by improving these lists. Like you can extend in both ways. Okay, so let's summarize what we do in this video. So firstly, we talked about the decision tree classifier, and then we imported main classification for the data creation, train test split for splitting our data into training and testing sets. We imported decision tree classifier, and we imported accuracy score for evaluating the models, and then we create our data with the 5 features with 3 informative ones and 2 classes, which is for having a binary classification problem. And then we use train test split like this on test size 0.2, which means that we are going to have 800 data points in the training set and 200 in the testing set. And then we initialized our base model. By the way, one reason that base model is performing better than the parameter tuned one is the list is not enough, like we don't have a lot of values in the defined list and it's trying to pick the best one from that list. So if we give more numbers, it's going to find better models. But one thing else is we have a non-real data set, so we created with code, so this is also a reason. And then we trained our base model, we make predictions with it, we used accuracy score and we get the accuracy. Then we talked about the parameters of the decision tree model we have, and we applied grid search for hyperparameter tuning after defining these parameters. And don't forget to expand the values in depending your problem and dataset. So we set the grid search with the 5 folds and scoring is accuracy. Then we fitted it and we check the best parameters, like here is our best values out of them, and we make predictions with the best estimator, then we get our accuracy score. Thanks for watching this tutorial on decision tree classifier. I have a machine learning tutorials playlist where I have more than 40 videos just like this one. You can reach the playlist from the cards of this video or from the description. I'm sharing new data science videos every week on my channel. You can subscribe for more videos like this. Have a great day.